Okay, now on to our next segment of this set of lectures. So the next question is not only just what is temperature, which we addressed last time. Temperature is a measure of the average kinetic energy of molecules. Um, but what are the different temperature scales we use? Now, the one we use the most here in the United States is Fahrenheit, although you'll find that your doctor doesn't really use Fahrenheit. Your doctor uses Celsius. And a lot of things for which we think are important, a lot of things we think are important, we've already converted to the metric system where we use Celsius. But temperature is operationally defined as what we measure with the thermometer, right? So the different scales we have are the Fahrenheit, the Celsius, and the Kelvin scales. All right, and if you look, you'll notice this has degrees Fahrenheit, degrees Celsius, but Kelvin is just by itself. So what we're going to look at is how you go back and forth between all of these and all of that. But right down here is exactly why you must keep a thermometer in your mouth long enough to get an accurate temperature. And what that really means is here in the zeroth law of thermodynamics, to take your temperature with a thermometer, it has to come in equilibrium, into equilibrium with your mouth. So you stick a thermometer in, it has to heat up or cool down, depending, but usually heat up. It has to heat up to the temperature of your mouth, reach thermal equilibrium with your mouth in order to give you an accurate reading of your temperature. It's important when we go through all of this that you know how to convert to different scales. One of the most important parts about this is really, if we go back to the equations we're going to have in different places, here, this temperature must be in Kelvin. All right, whenever we're using equations like this, the temperature must always be in Kelvin, almost always. There are a few exceptions, but almost always it needs to be in Kelvin. Well, how do you get from Fahrenheit to Kelvin? Well, first, there's getting from Fahrenheit to Celsius. So if you have your temperature in Fahrenheit, let's say your temperature is, let me pull up Excel. We'll just do this real quick. All right. All right, so here we go. Let's say your temperature in Fahrenheit is 98.6, right? You're feeling good. Well, how do you convert to Celsius? Well, to convert to Celsius, first, you're going to subtract 32 degrees. Why do we have to do that? Because 0 degrees Celsius, the point at which water freezes, is 32 degrees Fahrenheit. So basically we're subtracting out everything it takes to make 0 be the point at which water freezes. And then you have to take into account that a Celsius degree is bigger than a Fahrenheit degree by a factor of 5/9. So if you look at that, 98.6 ends up being 37 degrees Celsius. All right, so 98.6 degrees Fahrenheit is 37 degrees Celsius. Then we're going to convert to Kelvin. The difference between Celsius and Kelvin is really simple. While 0 for Celsius is set at the point at which water freezes, 0 for Kelvin is set at absolute 0. So to get from Celsius to Kelvin, we simply add 273.15, which is what it takes, which is the freezing point of water in Kelvin, right? So if you want to freak out your mother, call her up and say, "Mom, my temperature is 310.15." And your mother will freak out. You will tell her, "Calm down, Mom. That's Kelvin. That's Kelvin. That's not Fahrenheit. That's Kelvin." Right? So 310.15 Kelvin is a standard human body temperature. So those are the different temperature scales: Fahrenheit, Celsius, and Kelvin, and this is how we get in between them, right? and sometimes you'll want to solve for Celsius, sometimes you'll want to solve for Fahrenheit, but for the most part, these are the formulas you need. Okay, that's enough about temperature conversions, and we'll talk about some of the consequences of all of this in the next segment of the lecture.